Get ready to shatter your expectations. We've all been taught the same story about the oldest photo ever snapped view from the window at Le Graz, allegedly shot by Joseph Nisfort Neps in 1826. But what if I told you this tale isn't entirely true? Imagine a photograph that's not just centuries old, but a whopping 13 billion years older. That's right, we're talking about a snapshot from the dawn of time itself. Buckle up, because it's time to dive into some mind-blowing history and challenge everything you thought you knew about photography. The truth's about to blow your mind. And here's the amazing part. This isn't just some wild claim, you'll get to see proof for yourself. In today's world, with cameras in our pockets and every snapster thinking they're an Ansel Adams, it's easy to forget what a groundbreaking moment capturing an image was, especially when all it takes is a smartphone to become a photographer overnight. I bet many of you right now have hundreds, maybe even thousands, of photos scattered across your devices. A furry friend's adorable face, breathtaking sunsets, an endless series of selfies with mixed results, and some mouth-watering food pics. But there are images that stand way above the rest, ones that take our breath away, like the incredible shots captured by the Hubble Space Telescope. So, are you ready to find out what's got me stoked today? Let's dive right into the amazing story of how this superstar of space exploration came to life. Launched way back in 1990, the Hubble Space Telescope has been capturing awe-inspiring images non-stop ever since, and it's still going strong. Now, you might be thinking, wait, wasn't there a space telescope before Hubble? And you're absolutely right. There was. But here's why Hubble stands out. It's one of the biggest and most widely used space telescopes to date. So, what makes this telescope so special? Simply put, its incredible location, floating in low Earth orbit, high above the atmosphere, where the air won't distort or blur our view. But here's the thing, our atmosphere isn't just a hindrance for our daily commutes. It's also blocking some seriously powerful cosmic signals. Gamma rays and X-rays, for instance, can't even make it past our atmosphere, making them invisible to us from down on Earth. That's why having telescopes in space is absolute game changer. We get to uncover the secrets of the universe in ways that would be impossible otherwise. Now, let's talk shop about Hubble's super cool tech. Unlike cameras we use every day, space telescopes like Hubble rely on a brilliant system of mirrors instead of lenses. These mirrors are precision engineered to capture the faint light from distant galaxies and stars with stunning accuracy. The mirror and optical systems are essentially the heart and soul of Hubble's design and they're what make it all possible. But here's the thing, Hubble isn't just a jack of all trades, it's designed to be a master of many wavelengths. We're talking ultraviolet to near-infrared, the ultimate cosmic viewing range. For this kind of versatility, you need an incredibly special main mirror. And let me tell you, creating that one-of-a-kind mirror was no cakewalk. It took way longer and cost way more than initially anticipated. We're talking from 100 million to a whopping billion just for the American side. Throw in the European Space Agency's 151 million contribution, and it's clear Hubble's price tag was out of this world. But all that hard work and investment paid off when Hubble finally launched into orbit on April 1990, marking the beginning of an incredible journey through the cosmos. The moment of truth had finally arrived, or so we thought. Just a couple of weeks after its triumphant launch, scientists were hit with some devastating news. Hubble's mirror wasn't living up to expectations. It was all about sharpness, but this telescope was struggling to deliver. The culprit, a wonky polished job that left the mirror irregularly shaped, flat at the edges, but not quite right in the middle. It took a frustrating 3 years to iron out this issue and get Hubble's vision back on track. But once they did, get ready for some out-of-this-world photography. Hubble's been a rock star for nearly 3 decades, capturing millions of jaw-dropping images that have changed our understanding of the cosmos. But here's the amazing part. This space legend can see way more than just visible light. It's a master of all forms of electromagnetic radiation. And because Hubble gazes at the universe from up high, it can spot objects that remain hidden to Earth-based telescopes. Now, you might know that the universe is expanding like a giant balloon, taking space and everything in it on a cosmic ride. As light travels through this growing universe, its wavelength gets stretched out, almost like when you tune into an old radio station and it sounds all fuzzy. By the time that light reaches Hubble's lenses, its wavelength has grown longer than when it first set off on its intergalactic journey. You got it. This phenomenon is known as redshift. The further away an object is, the more its light gets stretched out on its cosmic journey, causing it to shift towards the redder end of the spectrum, much like when you're driving with the radio on and a station fades into static. As a result, if we see a lot of redshift in an image, it's telling us that the object is really, really far away, way farther than what our Earth-based telescopes can detect. So, Hubble's dream mission was to pinpoint the light from the most distant galaxy out there, and guess what? Scientists nailed it. They successfully spotted the light from a galaxy so mind-bogglingly far away that it takes its light about 13.4 billion years to reach us, almost since the Big Bang itself. Fast forward to 2016, when scientists made an incredible discovery. They found a galaxy called GNZ11. This super-distant galaxy is located in the direction of Ursa Major, and its light has been on an epic journey for about 13.4 billion years before finally reaching us. But here's the wild part due to the universe's expansion. When we look at GNZ11 today, we're actually seeing it as it was 13.4 billion years ago, a snapshot of the past that's truly out of this world. So, while GNZ11 might be only 32 billion light-years away in terms of distance, its light has been traveling through time and space to reach us, giving us a glimpse into the universe's distant, ancient history. Get this, when we look at the photos of GNZ11, we're essentially seeing images over 13 billion years old. That's right, the light from this ancient galaxy has been traveling through space and time to reach our eyes, giving us a front-row seat to the universe's past. It's wild to think that these photos are officially older than all the ancient artifacts on Earth. Even the pioneering photograph taken from a window at Le Graz in 1826 is younger by about 189 years. What we're seeing here is a glimpse of a distant galaxy, one that predates us all, and it's an awe-inspiring reminder of just how vast and mysterious our universe truly is. Fasten your seatbelts because things are about to get mind-blowingly cosmic. When we talk about space and time, the rules change. It's like an intergalactic game of catch-up. Our universe is estimated to be around 13.8 billion years young, with the Big Bang being the kickstart that began everything. So, when we gaze at the galaxy GNZ11, we're essentially taking a peek at what its past looked like, and it's an incredible 400 million years after the universe's birth. That's right, we've got our hands on a cosmic time machine of sorts, giving us a jaw-dropping glimpse into the distant past. It's a reminder that we're not just observers, but also guardians of the universe's secrets and mysteries waiting to be unraveled. Let's dive into the cosmic dawn. It's like stepping into a mysterious chapter of the universe's history book. Scientists are convinced that galaxy GNZ11 is just a stone's throw away from the end of what they call the Dark Ages, a period when the first stars started forming. Imagine a world with no shining beacons, just an endless sea of darkness. This was our universe's early days. It wasn't until the Dark Ages came to a close and the Matter Era began that things lit up, marking a pivotal moment in cosmic evolution. But we're not there yet. We've got a long way to go before we can witness this spectacular transformation with GNZ11. The wait might be worth it though. After all, who wouldn't want to see the birth of stars and a brand new era for our universe? You won't believe how we spotted this incredible galaxy, GNZ11. It's located right at the edge of what the Hubble telescope can see, and we're talking luck on a cosmic scale here. A rare alignment of stars had to happen for us to catch a glimpse of it. The surrounding space was just reionized enough that our telescope could capture a relatively clear image, and that's with considering its mind-boggling distance from us. But wait, there's more. The light coming from GNZ11 got an unexpected boost as it passed through another galaxy. This galaxy acted like a gigantic cosmic lens, magnifying the distant light for us to see this ancient marvel in all its glory. Talk about a celestial trifecta of good fortune. Imagine if that light from GNZ11 just sailed right past Hubble without any help. We'd be none the wiser about this ancient wonder. But gravity being gravity, it did its thing and bent that light's path our way. And voila, we've got a glimpse of history dating back over 13 billion years. Now, you might think GNZ11 holds the title for the oldest image ever captured, but hold on, there's more to the story. Another contender, EGSY 8P7 in the constellation Camelopardalis, was actually the previous record holder. So while our new friend GNZ 11 takes the crown, it's not alone in showing us what our universe looked like eons ago. Mind-blowing fact, it took the light from GNZ 11 an astonishing 13,200,000,000 years to travel all the way to our planet, just to be snapped by Hubble's camera. That's over 13 billion years of cosmic journey before getting its picture taken. But hold on, there's another galaxy called A20744YD4 that stole the show with a timestamp of just 600 million years after the Big Bang. Talk about timing for a photo shoot. And it's not just galaxies taking center stage. Fasten your seatbelts because a massive gamma ray burst named GRB 90423 lit up the universe on April 23, 2009. The thing is, this mind-boggling explosion of energy happened an eye-watering 13,035 million years ago. Buckle up, space fans. We've just confirmed that massive stars were born, lived, and died an astonishing 630 million years after the Big Bang. Talk about a speedy life cycle in the young universe's fast lane. But wait, there's more. On December 6, 2017, astronomers made history with the discovery of a far-out quasar called ULAS J1342 plus 928. This cosmic giant is not only the farthest known quasar, but also has a connection to our universe's oldest supermassive black hole. Can you believe it? With an insane mass of 800 million times that of our own star. This space behemoth is truly one for the books. Let's dive even deeper. When we gaze at ULAS J1342 plus 928, keep in mind that its light has been on a cosmic road trip. It took about 13.1 billion years to reach us. That means, essentially, we're seeing this quasar as it existed nearly 13.1 billion years ago. This astronomical time-traveling trick allows us to study the universe's past and draw some mind-blowing conclusions. It's a total game changer. For the first time, we're associating the cosmos not just with the unknown future, but also with the ancient secrets of our past. The universe is full of mysteries waiting to be unraveled. Gaze up at those twinkling lights in the sky, a celestial